Universiti and my matric number is 270415. And today I will be talking about the Taguchi Airplane product design. This project topic is an experimental which involved to illustrate the Taguchi Airplane product design. This product design is to sustain the effective of quality controls that require a technique that focus on making quality. Firstly, it initiate three-step process, which is system design, parameter design, and tolerance design. In this experiment, Taguchi had implement the quality management and the experimental design that mostly involved to the parameter design. The parameter design had imaged the process to shorten the airplane development time, to improve the quality based on budgetary costs, as well as the analysis of the advantages. Furthermore, the process in Taguchi method is in reducing costs of enhance the quality was simple and straightforward. Had increased the interest in develop the design of experiment. This activity allowed us to run experiment to see how 4 different parameters affect the fly distance of a paper aeroplane. In each that involve 3 stages. The total experiment that we need to conduct equal to 45 experiments, which take to build 9 aeroplanes with 5 repetitions, and those repetitions in the experiment help in acknowledge the necessary of charge, necessary of change, and the effect of each factor that can be decided by along with the help of well-defined experiment subset. A confirmation experiment was run on one system, and the results were subtainted. And the goal for this experiment for us is to be able in identify the best type of Taguchi airplane with the right design parameter that had been required.
Hello, my name is Qurratu Aini binti Musa with a matrix number of 275342. So I will continue the presentation, which is first I will talk about the philosophy of Taguchi's method. So Taguchi's method is an approach that is often used in engineering experimental. It is used because of its strength in quality control in manufacturing industries. It also used because of this method is said simple, efficient, and systematic to optimize the design, cost, and performance in experiment. Based on the study, it is said that Taguchi's method emphasizes the quality variation is the main opponent of the quality engineering. So that is why a lot of effort should be taken to reduce the variations in the quality criteria. So Taguchi's method is based on 3 concepts, which is first the quality must be planned into product, but not by its examination. And the third concept and the second concept is in order to accomplish the quality, it is best to avoid the deviation from the target, so the product that is produced is not very sensitive to any environmental factors that is out of ability to control. And the last concept is the cost of the quality is being measured as the function of the deviation, and as for the losses is measured the system-wide. Okay, next is I will talk about the Taguchi's tool or methods for robust design. So robust design is the engineering methodology which is to improve the quality of product and its process. So when there is the improvement, a high quality product is able to produce, and at the same time to able to minimize the variance that may affect the quality of product and the cost of manufacturing. The tools or methods in robust design there are two, which is first parameter design. It is to find the suitable design factor levels to reduce the sensitivity of the product due to the variance of uncontrollable factors. And the second one is the tolerance design. It is to minimize the cost of manufacturing product. However, there are two major tools that is used in robust design, which is first signal to noise ratio, and the second one is the orthogonal arrays. Okay, next I will talk about the Taguchi's method in experiment. So in experiment, Taguchi's method is recommended because it can study a large number of variables, but in a small number of experiments. This method can help to determine the number of experiments that is needed with the factors provided and the level of each design in the experiment. So the factors can be grouped into noise, control, inductive, block factors, and signal adjustment. And the noise factor can come to from three sources, which is first is unit to unit variation, and the second one is external factor, and the third one is the internal factor. So lastly, I will talk about the concept of loss function. This concept is effective tools that can be used for quality engineering. The quality losses happen when the product deviates far from the target, which as the result, the product is unable to be accepted. So, this concept focuses to accomplish the satisfaction of the customers and those other interested parties. This satisfaction is based on four aspects, which is first the effectiveness, and the second one is the efficiency, and the third one is economy, and the lastly is ethics. In Taguchi's loss function, there is three types of function, which is first is the nominal is best characteristics, second one is smaller is better characteristics, and the lastly is the large is better characteristics. So I will pass to the next presenter to present the presentation.
Hi, my name is Nurul Fazira Hanim binti Ahmad Fauzi. My metric number is 270479. I will represent to you the methodology of our group. Okay, the reason why we include the methodology in our experiment is because it can be our guideline in interpreting and solving the problems. In this experiment, we are using the Taguchi methods that assess the impact of the final quality product. There are three steps that we use to create this design. First step is parameter design. Before we get started, we will identify the concept and the nominal values before designing the product. This will help us finding the most important factor that produce a variation in quality characteristic. The term that we use in this experiment is robust parameter design. Second step is select orthogonal arrays. This step is to set the parameter and the level at which they should be updated. But before proceeding to this step, we need to complete the calculation for each parameter in the experiment. The last step is we are using the signal of noise ratio or SN ratio. This step is to consider the mean and uncertainty of the experiment result. This step is determined by the quality characteristic to develop. There are three efficiency, which is there are three type of efficiency in this step, which is the lower the better, the higher the better, the nominal the better. For each calculation answer in this step will be analyzed and the answer that reach the higher characteristic performance will be chosen as the best. That's all from me. We will continue to data analysis. Thank you.
Salam sejahtera and hi, my name is Siti Zulaika binti Yazid, my metric number 270267. So I would like to present about the Taguchi Airplanes design analysis table. In this experiment, we will have a results for data analysis is SN ratio analysis. Based on the analysis data, as we can see, the longest distance in mean distance is experiment 1, which is 462.2, and the shortest mean distance is 261.12 by experiment 7. Meanwhile, the longest in distance in standard deviation is experiment 9, which is 64.06, and the shortest standard deviation is 15.45 by experiment 2. Besides, the longest distance is SN ratio is experiment 1, which is 27.24, and the shortest SN ratio is 16.33 by experiment 7. Based on the tables, determine the design parameters affecting the process. Parameters are variables within the process affect the performance measure, such as wake location, stabilizer setting, nose length, and wing angle that can be easily controlled. The number of levels that parameters should be varied at must be specified. For instance, a stabilizer setting might be varied to a low and high value of 309.77 and 386.61. Increasing the number of levels to vary a parameter increases the number of experiments to be conducted. If the difference between the minimum and maximum value of parameter is large, the values being tested can be further apart, or more values tested can be closer together.
So I will continue the presentation for the discussion part. So for the first question in the discussion, what can you say about the effects of the different factors on flight distance? What levels of each factor would you use to maximize flight distance? So what we come up is the different factors make the flight to fly at a different distance. So based on the experiment, the flight which the factor of wake located at A1 is best to be used to maximize the flight. It is because when it combines with the factors such as the stabilizers at B1, nose length at the C1, and the wing angle at the D1, the flight able to fly with the longest length or distance before it land. So for the question 2, what can say about the effects on the different factors on variation in flight distance? What levels of each factor would you use to minimize variation in flight distance? So what we come up is the different factors on variation influence the distance of flight to fly before it land. For instance, at certain level with a certain factor on variation can make the flight fly either in the in short or long distance. So based on the experiment, the flight with the factor of wake located at A1 and the factor of nose length at the C1 able to minimize the variation in flight distance. So, this is the best to be chosen in using to minimize the variation in flight distance. So next in question 3, is the SN ratio a reasonable way to capture both goals to maximize distance and minimize variation? Can you specify an optimal design? Why or why not? So what we come out is yes, SN ratio is reasonable way to capture both goals. By referring to the results of experiment, the optimal design is best when it is designed as in the experiment 1. We choose this because the result shows that when the flight is designed as in experiment 1, the flight distance is longer and it able to fly further means that it able to minimize the noise. So that's all for me. Thank you.
Okay, for the conclusion, the Taguchi approach has ability to influence the level of factors that influence quality, characteristics that are not convenient. This method is required by the industry in order to conduct experiments that improve process and product quality. Experimental design is a fundamental step in improving a product quality in this regard. Furthermore, a well-designed set of experiments in which all relevant parameters were shifted during a certain range. This is far more efficient method of gathering systematic data from experiments. We were also able to analyze experimental data from flight experiments and determine the best parameter combination for various paper plane designs using the Taguchi method. The result of this experiment are used to describe the experimental and analytical process that lead to determination of the best set of parameters. That's all from us. Thank you.